So let's talk about electrolytes. What are these? This is actually from chapter 11. So if you check your reference, I think it's 11.4. Just look at the syllabus for the schedule. So what is an electrolyte? We're going to define electrolyte, weak electrolyte, and non-electrolyte, and then we will identify electrolytes and weak electrolytes and non-electrolytes. This may surprise you, but water by itself does not conduct electricity very well. In fact, when we purify water to very low concentrations of contaminants, we take the resistivity of the water to measure how well we did. So we want to know that it's very resistive. So why do we advise people to stay out of water when there's a lightning storm? Turns out, water is called the universal solvent for a reason. It dissolves pretty much anything it comes into contact with, generally in small amounts. But wait, our solubility rules tell us that there are insoluble things in water. Yeah, that's true. Some things are insoluble in water, but generally speaking, most of those things will dissolve a tiny bit, just a skosh. And we call it insoluble because that tiny bit is not very notable. Water you find outside in the world is always a mixture of various materials it has flowed over and through, and so it conducts electricity because those things include electrolytes. So what is an electrolyte? Electrolytes conduct electricity in water because they dissociate into ions. The ions conduct the electricity. They have charge, so they move the electrons along. Examples of electrolytes include ionic compounds like sodium chloride and potassium nitrate. They include any ionic compound on which you place an AQ for aqueous in the chemical equation. They also include all acids and bases, which incidentally do not have to be ionic compounds but still dissociate. A weak electrolyte occurs when the compound that is dissolved does not fully dissociate. Examples are all weak acids and bases, and ionic compounds that are only slightly soluble. And finally, non-electrolytes dissolve in water, but do not dissociate, so we don't make ions. These include all organic compounds that are soluble in water and are not acids and bases. So unless it contains a COOH group, and I'm going to write that out, all right, we will try this again. COOH. Okay, so it'll have that in the formula, or an NH sub X. So this is an amine group and a carboxylic acid group. Both of those will dissociate because one is an acid and one is a base. Okay, so if it's not one of those things and it's an organic compound, not going to dissociate. So here is our visual of what is going on. It includes both macroscopic and microscopic views. The macroscopic is the light bulb with the plates, and the microscopic is the molecules and ions represented in water. Obviously, those ions and molecules are not to scale. A non-electrolyte, which has dissolved but not dissociated, will not be attracted to charged surfaces and thus cannot conduct electricity in water. An electrolyte will have ions and does move towards charged surfaces, so therefore does conduct electricity. And finally, a weak electrolyte contains both dissociated and non-dissociated species. So it conducts electricity, but there are fewer ions to move, so it conducts electricity poorly. This is an actual demo you can look up on the interwebs if you would like to see it. It works best with incandescent bulbs, as you can dramatically tell the difference between a weak and strong electrolyte, but it is still going to work if you don't use an incandescent bulb. So why does an incandescent bulb work better? It takes more electricity to light up an incandescent bulb. So you see more of a change in how bright the bulb is. I think this visual really drives the definition home in ways that the words don't. Lighting up a light bulb really says, I conduct electricity. So let's practice. Identify the following as strong electrolytes, weak electrolytes, or non-electrolytes. You may find your solubility rules to be helpful. So pause on this page and try to figure these out. And then the answers are in the next slide. Okay, so lead chloride is in fact soluble. It is an ionic compound which does dissociate, therefore it is a strong electrolyte. Sucrose, or sugar, is soluble, does not dissociate. It does not have a carboxylic acid group. It does not have an NHX group. It is a non-electrolyte. Nitric acid is soluble and a strong acid, therefore it is a strong electrolyte. Any strong acid is going to be a strong electrolyte. Any strong base is going to be a strong electrolyte. Methanol does not have a COOH group. It does have an OH, but not a COOH. So it is soluble, but it does not dissociate. It is a non-electrolyte. And finally, calcium sulfate is slightly soluble. So it does dissociate, but it is a weak electrolyte because it is only slightly soluble. So to summarize, electrolytes conduct electricity in water because they dissociate. Weak electrolytes only partially dissociate, so they conduct electricity poorly in water. And non-electrolytes dissolve but do not dissociate and therefore do not conduct electricity in water.